Hello everyone, welcome to the lecture 1 of Introduction to GIS. This lecture series is on behalf of Center of Excellence in Land Administration and Management, which is an initiative of DILRMP, Department of Land Resource, Ministry of Rural Development, Government of India, which is housed at the Administrative Training Institute, Government of Karnataka, Mysuru. Since the land administration and management directly linked with the geography, then the modern geographical applications like GIS will going to be helpful for us to study how we can efficiently manage the land and how it can be beneficial for the general public. So for that we are going with the lecture 1 introduction to GIS. So the GIS is the modern geographical tools where we use to study the geography. So most of you have heard about the word GIS somewhere in the studies and somewhere in your professional career, somewhere in the trainings or somewhere in the newspapers. So what is this GIS, right? So GIS is a geographical, and I stands for information and S for system. The word G, it's nothing but the geography. So that means we are going to study about the geography. Geography is nothing but the earth. So the geography is a study of places and the relationship between the people and the environment. Then what about I? I is the information. So what are all the information at the particular geographical location that we are going to study. Let's take the example. If we look into the geography of the particular earth, the particular place may have the boundary, administrative setup, or it may be having the location with respect to the earth. So the feature whatever we are studying that comes under the geography. Let's say I want to study the location of the India. Where is India, right? The boundary and the demarcation, everything comes under the geographical context, where it contains the area, length, all the geographical measurements, and whatever the measurements we done with respect to particular location, then that particular location might be having some information like the attribute at the particular location. So in this case, so we say that as in India. And if you look into the another example, like in the South African region, I want to study the temperature of the particular location. So the South Africa, the location is nothing but the geography, and whatever the information in that particular location that we are gathering, that is nothing but the information. Then we have a location information and we have a attributes. So location plus information is nothing but the location of a particular geographical feature, let's say a lake, and the information about the lake, like a lake name, lake extent, the water quality, different parameters will come under the information part. So we can embed both geography and its associated information together in the form of system, and all together to be called as geographical information system. So if we look into the different sources from the internet, from the different books or some different magazines, case studies, research, often we see that different terminologies in the GIS. So as we discussed that GIS stands for Geographical Information System. So that means mainly we concentrating on the geographical space, right? Other terminologies like geomatics are used. So geomatics is a compound word which is a combination of geography and mathematics, where in geomatics we mainly concentrate on the mathematical part on the geography, like the measurements, aerial measurements, linear measurements, and measuring of the circumference of the earth, measurement of the radius of the earth, measurement of the elevation of a particular mountain, measurement of the depth of the ocean from the shoreline. So these are all the things, all the mathematical part and the geography which comes under the geomatics. If we look into some other terminologies, we often see that the word geoinformatics. The geoinformatics is a umbrella concept where multiple technologies which supporting the geographical analysis all together brought under one umbrella, and everything comprehensively to be called as geoinformatics. In the later on stages, we will see what are all the different technologies that is currently being used in the market to study the geographical space, right? And the fourth terminology is the spatial science. So often we see the word spatial. We will discuss in detail what is that spatial science, geospatial science, and geospatial technology. So these are all the limited terminologies we have listed, but different people from the different region may call in a different terminologies, but often everything is subjected to the mapping of the earth system and the changes happening in the earth. So as I said that the word geospatial. So what is the term geospatial? Again, the geospatial is a compound word which is derived from geo plus space, and it become a geospatial. So we know that the geo is nothing but the geography, and if we look into the space, different domain people will call the space in a different manner. Let's take the example of the physics. In the physics, if we say space means obviously the physicist will discuss about the astrophysics part, where the celestial body, universe, uh, the empty space in the outermost part of the atmosphere. But if we ask what is space to the geographer, uh, the geographer says that the space is nothing but the surface of the earth. So why not geo means geology? Why specifically geography? Why? Because this GIS technology mainly brought to the market by the geographers in 1970s, 1980s. So the contribution of the geographers are main in the development of the GIS, but later on stages different domain people adopted the geospatial technology, and now it is an interdisciplinary science. But in the early stages, the contribution of the geographers are tremendous, and even the development of coordinate system, how to locate the particular feature from one place to another place, and how we can sail, the Portuguese contribution also there in GIS, and the development of coordinate system that we will discuss in detail in later on stages. Right. So as I said that it is a compound word, geo plus space. Geo is nothing but the geography, and the space is nothing but the surface of the earth, together to be called as geospatial. So geospatial means it's nothing but we are studying about the surface of the earth. So if we look into the definition of the GIS, the proper definition of the GIS is not existing. Why? Because different textbook, different authors says the definition of GIS in a different way. But if we look into the broader view, the geographic information system is a computer system. Why? Because it is a modern technology. Often we use a computer system to map the earth. So traditionally what we done is all the geographical space are handwritten, but nowadays we are not going to prepare the handwritten maps. majority of the maps are compiled through computer system. So that's what a geographic information system is, a computer system, modern IT system that stores, manages and analyzes data about the earth, right. Okay, so how this particular GIS works? GIS used to capture data about the earth surface such as streets, buildings, vegetation and other relating to geography. So once the data is collected, then the collected data will be linked to location, that is the latitude and longitude. So if you are not aware about the latitudes and longitude, how latitude and longitudes are formed and what it signifies, for that also we have a specific lecture in an upcoming series. You can watch that, right. So in this phase what happens, the data will be linked to the location, that is we also call that as a GI tagging or a geo tagging. The data will be geo tagged. Let's say the particular species of a tree, the tree latitude and longitude, that will be spatial data, that is nothing but relating to the space, and for the particular tree we have a mathematical location in terms of x and y. The x and y further linked with the species name, height, girth size, what kind of kingdom, all the whatever the informations we have with respect to particular tree, that can be integrated with the latitude and longitude. So in the early phase, as I said, that the GIS used to capture the data. Once the data is captured, then the data will be linked to latitudes and longitude. Then if we look into the different types of data, the aerial photographs, this is the example of aerial photograph, where aerially captured through a different sensors like a drone, like a aircraft, like a satellite imageries, all are aerially flying. Even you can go with the hot air balloon and you can capture the photo of a particular location aerially, that also will become a aerial photograph. So if we look into the history of aerial photography, then the aerial photography started from the capturing of aerial photograph through pigeons. So the history is interesting. So if you want to explore more on the historical context, then we have to go back and we have to look into the different events that is happened across the different time periods. But right now this is enough. So aerial photography, why? Because majority of us aware about the drones, satellites and other mode of aerial imaging system. Right now this aerial photographs act as the data for us to capture the building information, building footprint information, and what are all the trees, the tree canopy size, how the crowns are, what is the diameter of the canopy, what is the radius of the canopy, what is the width of the road, and whether the width of the road is homogeneous across the line or not, the center line of that. So whether the particular house having a solar panel or not, or a swimming pool or not. So what is the extent of the built up, what is the extent of the green space, all the things we can able to capture if we have a data. So this is the aerial photograph. And if we look into the satellite imagery, the satellite imagery also gives us the data about the particular location. The accuracy, the clarity of the satellite imagery depends on the sensors that the satellite uses, and whatever the data providers they are providing, that we need to take care of. If we look into the historical context of the satellite imageries, we have a satellite image from the year 1972 to till date. So we can study how a particular location evolved from one time period to another time period, from 1970s to till date. So we have a historical images. So even you can use the scanned map, and through this scanned map also we can able to prepare the recompile the maps through the help of geographical information system. Once the data are stored Then once the data are compiled, then the ultimate task of the GIS is to create the visualization. So in the visualization we are going to tell the stories. It is also called as the storytelling, or we can use GIS for preparation of the maps. These maps can represent the information about the geographical space. One of the data that we use regularly in land administration and management is the topographical sheet from the Survey of India. So that is one of the best example. You can explore the topo sheet, which is freely available from the Survey of India website. Across the India, nearly 5,000 sheets are there to represent the entire India at the scale of 1 is to 50,000. So we will discuss what is these scales, and regarding the topo sheet, what all the components are there, how to interpret, how to read the topo sheet. So everything we will discuss in the upcoming lecture series. So this particular presentation is regarding giving a broad idea about how GIS can be beneficial for the land administration and management. Okay, let's take an example on how GIS can be used to solve the geographical problem. So often we use the 4 W's of GIS. So these are all the fundamental questions of GIS. The what is that 4W means what, where, when and why. See, whatever the problems you take from the geography, always you consider these 4 W's. So once we identify the answers for these 4 questions, then we can able to solve all the geographical problems that is happening around us. So let's look into the first question, what. This what is nothing but what we are studying. Where means where we are studying. So where it is. Let's take the example of the forest fire. What we are studying, so we are studying the forest fire. Where the forest fire is happening, so it's nothing but the location. Let's take the example of the California. Recently California wildfire has happened. So what is the what is nothing but the forest fire, where it is happened in the California, when it is happened, the time component. When means the time component, and date and time component. Then why, so why the forest fire happened in that particular location, why not in another place. So what are all the driving forces behind the particular phenomena. So these are all the questions that we need to address in order to solve the geographical problem. Let's look into the one example. So what we are studying, the urban growth or the natural disaster or even man-made disaster, whatever are other process or event. Let's take the example of temperature, pressure, humidity, the sea level rise, the global warming. So all the examples you can take. So what we are studying, so we are studying something about the geography always. So that's what we are studying is the ultimate question in the GIS. Then where, the location or a spatial aspect of the data. So where that particular phenomena is happening, whether it is in a north pole or whether it is in a south pole or whether it is in an equatorial region or whether it is in a particular location, right. So the location aspects we need to define, and where it is, so where the urban area is and where the natural disaster happened. So these are all the things that we need to think of when we want to solve the geographical problem. Then when it comes for the when, the temporal aspect. So the word temporal means through the time. So how the particular phenomena changes through the time, through the date, through the year. So how and why, right? Why the particular thing as changing from one time period to another time period. So these are all the things we are going to discuss in the when component. Let's look into the closer aspects of the urban area. If you look into the Bangalore, so the Bangalore is the capital city in the state of Karnataka, where the population growth is very high, and even the expansion of urban area also very high over the period of time, because of Bangalore is the Silicon Valley of the India, and majority of the migrants are dwelling in the Bangalore, and the lot of pressures are inserted to the land, and the built up areas are continuously growing, right. So what I'm studying the urban growth. Where I'm studying in a Bangalore. So whether you are studying at a particular year or whether you are studying throughout the year or you are studying at the different time period. Let's say I want to know what is the urban area at the year 2000, what will be the urban area at the 2010 and how it is in the 2025. So if we look into the trajectory of this temporal aspect, then we can able to easily predict how the urban growth may happen in future up to 2050 or 2100. So if the particular urban expansion is happening in a sustainable way or unsustainable way, whether it is resilient or not resilient. So these type of questions that we need to frame when we do the geospatial analysis. Then ultimately the fourth question is the why, the decision making and the problem solving. So once we have an idea about the growth of a particular city, where it is growing, or whether it is growing with a particular location, or whether it is shrinking, or whether it is forming informal settlements, what causing these informal settlements, whether any policy is implicating or any policy is modifying or altering the urban growth. These are all the things that we need to take care of. So once we have a complete idea about a particular location, so then what we need to do is we have to do the decision on based on the data. So here decision making and problem solving, whether we need to restrict a particular urban growth in a certain area or not. So if we restrict, then what will be the benefit? So what if scenarios we need to build based on the data sets. So these are all the things that will come under the GIS and as well as the application with respect to land administration and management. So urban area, the expansion of urban area is also one of the problem in land administration, how we need to give the facilities to the public. These are all the things that we need to take care of as a urban planner, as a decision maker, as a stakeholder. So if we look into the functions of GIS, so once we know the 4Ws of GIS, then we have to go into the functions of GIS. The main functions of GIS is for the mapping and visualization, creating a digital maps with layers representing different spatial features, spatial analysis, so measuring distances, identifying the pattern, and analyzing the relationship in data, geocoding and location analysis, converting addresses into geographic coordinates for mapping, remote sensing integration, use of satellite imageries and aerial photograph for environmental and land use studies. So decision support, assisting in urban planning, disaster management, agriculture, transportation, military, anything. So we have a lot of applications that we will discuss in the upcoming lecture series. So these are all the functions the comprehensively discussed. By this I am going to end the lecture 1. So we will discuss more on the GIS in the lecture 2 and its applicability to the land administration and management, how we can leverage the GIS and other supporting technologies to solve the land problems that we will discuss in detail. So thank you everyone, and I hope you gain some knowledge from this lecture, and please visit our website and follow us at the Instagram, YouTube, LinkedIn, and if you have any queries you can write us at the our email account you can write. And by this I am going to end the lecture. Thank you everyone. Have a nice day.